Let's have a look at the Blinky project used. For this, we have to open MPLabX, which I have opened already, and then we open the right project. In this example, I will use the microchip Blinky SAM-E54 for the MCLV2 board. So I have to go to the right folder to open the project for MPLabX, Blinky LED SAM-E54 PIM MCLV2. I set it as a main project and I open Harmony 3. Within the Harmony 3 configurator, we now see the required blocks. So we have added the X2C model block, which is communicating with the SERCOM block through the UART interface. We are using the TC0 for the execution of the model. Anything else is optional. Also for the interrupt for execution the model, different options are available like PWM interrupt and A to D converter interrupt for motor control applications. The next step is to open the model in Scilab. The easiest way for this is if you have the path tool installed in MPLabX, you find the x2c.c file, which is under source files, config, SAM-E54 PIM MCLV2, x2c code, x2c model. This is always the place for the x2c.c file in an Harmony 3 project. So you click on the x2c.c and you open the file location with the Windows browser. You copy the path and you open Scilab. Once Scilab is completely loaded, you go to the file browser and you copy your path. You will end up in the location where you will also find the corresponding ZCOS file. This is the model file for your project. You double click on it and the model opens. If the model also has init project.sce script, it's highly recommended to execute it at this time. For this, we go back to Scilab. We don't see one, so we don't have to execute it. So now we are ready to simulate our model. We can do this by clicking on this icon here. Simulation starts. Simulation diagrams are coming up. We can do a modification. We can change the frequency. So let's increase the frequency by a factor of 10. So we just remove a 0 here. This was the frequency input for the three-phase sine signal. So at the next simulation, we see a 10 times higher frequency on the three-phase sine generator. Now we want to generate the C code from this model. So we start the communicator, transform the model and push it to the communicator. So this makes the model available in the communicator. Once it is done, we will see the communicator says model set. This means we can generate code by clicking on the icon here. So created code successfully, model XML file, write OK. If we now go back to MPLabX, we look at our file, we will see that it was just generated. So we have ready source code for our model, which we now can program onto our hardware in the next step.